I'm Ranga Karnam. I'm 10x certified in AWS, Azure, and Google Cloud as well. Our courses are helping thousands of learners do their cloud certifications in AWS, Azure, and Google Cloud. In this video, let's focus on Google Cloud. In last series of videos, we focused on AWS, Azure, and in this video, we'll be focusing on understanding Google Cloud and the different services which are present in Google Cloud. We'll be exploring more than 50 services which are present in Google Cloud, and we'll be using a full stack application as an example. So are you excited to get started with Google Cloud? Let's get started. What we have as an example is a very, very simple full stack application. You have a front end. This can be React, Angular, Vue, whatever you'd want. And the REST API might be a Java Spring Boot based application or a Python Django based application or a Node.js application or any of the other languages which can be used to build a REST API. And you have a database which the REST API talks to. So this is kind of a full stack application flow we'll be focusing on at the start. And at the later point in time, we'll also shift our attention to an analytical workflow. Let's not worry about the analytical workflow for now. Let's focus on the full stack one. And out of the things which are present in here, the one which interests me the most is the REST API. So let's start with REST API. I would want to deploy a REST API which is built using Java or Python or Node. What do I need to do? Typically, the first thing I would need to do is to create a virtual machine. So I'll create a virtual machine, and probably I will choose the right OS, a Linux OS, install Python 3 or the runtime you would need, install the code, and probably configure it a little bit. That's the typical approach which is used if you are running application in a data center, right? If I take this approach further, if I want high availability, if I would want to be able to scale to a lot of users, what I can do is I can actually add multiple VMs, right? So just with one VM, it's not great, because if this particular VM goes down, then what would happen? The entire thing becomes unavailable. And that's why you'd want to extend it to multiple VMs. By having multiple VMs, you get high availability. If this VM is able to support 10 users, now we'll be able to support about 40 users very, very easily. That's scalability, right? So to be able to support more and more users. And what we are using in here is horizontal scalability. What we are doing is, instead of making the machine bigger, instead of going for a bigger VM, bigger virtual machine, what we are doing is we are going for a number of virtual machines. This is the kind of setup that we are creating. Instead of having one VM, we are creating 4 or 10 or 100 VMs. When you are increasing the size of a specific VM, increasing memory or CPU or the storage which is attached, this is called vertical scalability. However, what we are making use of right now is horizontal scalability. In the cloud, typically you would go for horizontal scalability. Why? Because if you go for horizontal scalability, if this is not available, then the application can be served from the other instances, and you can bring up a new instance quickly. So horizontal scalability is recommended in the cloud because it also increases availability. So what we are talking about is the fact that we have multiple VMs now created. Is it sufficient if you have multiple VMs? Who would take care of distributing the load to them? We would need to have something in place. And that's where you would create a load balancer. So you would create a load balancer. Oops, let me get this right. So you would have a load balancer, which would be balancing the load between all these things. So you would be distributing the load from here. So the user would be first coming into the load balancer, and then you would be distributing the load across multiple VMs. Now, imagine setting this up in the cloud. It's not easy, right? You have to, for each of the VMs, you have to do the setup of the OS. You need to install the right software, install these, install the right applications, and then configure them. So, and you need to do that over a number of VMs, and you also need to create a load balancer. Doing this is not very, very easy. Before we get there, what we'll talk about are the different services which can be used to set up a simple structure like this, right? You'd want to do this in Google Cloud. What are the services that you can make use of? If you want to create a VM in Google Cloud, the service you can make use of is Google Compute Engine. Google Compute Engine allows you to choose, okay, this is the type of VM I would want to create. This is the operating system I would want installed on it. You can connect to it and install whatever software you'd want on the VM. So that's GCE. Now, we don't want just one VM, right? We want a group of VMs. when you want to create a group of VMs, you can go for managed instance groups or managed instance groups. In the case of managed instance groups, all the VMs are very similar. So they have the same kind of setup. That's why we would go for a managed instance group. And we want to have a load balancer. So we'll go for cloud load balancing. So cloud load balancing is the service to be able to create the load balancer in Google Cloud. So for this simple setup that we have in here, we need to create a managed instance group with a number of Google Compute Engine virtual machines, and you would use Google Cloud load balancing to distribute the load between them. The problem with this kind of a setup is you are responsible for everything. You are responsible for scaling, you are responsible for availability, you are responsible for operations. If you want to make a change on the VM, you need to go in, make the change yourself, right? So there is a lot of responsibility that you are taking up when you are going for this kind of setup. And that's the reason why in cloud, you would not typically go for this kind of setup. What we would do in the cloud typically is to go for managed services. So the cloud managed services typically provide you with a number of features to reduce your responsibilities. What kind of features are we talking about? The cloud managed services typically take care of scalability. You don't need to worry about how to scale it to number of instances. If you configure the right metrics, scalability would be taken care of. Some of these also provide auto scaling. You can say, this is the metric you need to look at, and if the metric is right, if there are not sufficient number of VMs to handle the traffic which is coming in, increase the number of VMs. So you can configure the metric to do that based on, and it would be automatically done for you. This is called auto scaling. You can also, they also take care of availability. You can configure health checks, and if the health check on a specific instance fails, the instance would be automatically replaced by a healthy instance. And operations as well. You don't need to worry about what is the operating system, what is the software version that is installed. All that you need to worry about is the code. And in Google Cloud, the managed service, the basic managed service for compute is called App Engine, Google App Engine. This is also called GAE. So Google App Engine is a managed service. You can use App Engine. All that you need to provide as an input to App Engine is your code and the configuration. So you'd provide code and a little bit of configuration as input, and it would, or App Engine would take care of everything. You don't need to worry about how to scale it, how to make it available, and all that stuff. App Engine would automatically take care of it. You can deploy Java, Python, Node, and a variety of other languages as well to App Engine. So the first managed service for compute in Google Cloud is App Engine. The other option you have in Google Cloud is to go for Cloud Run. Cloud Run allows you to run containers. So if you have a Docker image or an OCI compliant image, you can use Cloud Run to deploy it. Instead of actually deploying OS, runtime, application, configuration, everything, what you can do is you can create a Docker image which has all of these parts inside. So when you have a Docker image, you don't need to worry about all this. Docker image already contains all this. You can provide this Docker image to Cloud Run, and Cloud Run would be able to automatically run it for you. Again, Cloud Run takes care of availability, scalability. You don't need to worry about operations for it as well. It integrates with all the operation-related services of Google Cloud really, really well. Now, if you don't want to, Cloud Run and App Engine are really, really good when you have just one application and you would want to create multiple instances of that application. So hundreds of instances of a specific application, or if I have 2 or 3 applications and I would create huge number of instances of them, that's fine. That's when you go for App Engine or Cloud Run. But let's say I have thousands of container applications. Let's say I have a microservices architecture in place. So I have different microservices which are talking to each other. Let's call these M1, M2, M3. So I have thousands of microservices like this, and I would want very, very complex features for these microservices. In those kind of situations, App Engine and Cloud Run are not sufficient. You need to go for something called container orchestration. So what you need to make use of is container orchestration. And the most popular container orchestration solution in the IT world today, what is it? It's Kubernetes. And Kubernetes service is also available in Google Cloud. What is the service that's available in Google Cloud for Kubernetes? It's GKE, Google Kubernetes Engine. When you're making use of Kubernetes, you'd create a cluster. So you create a cluster. The cluster contains a number of nodes, master node and worker nodes. So you'd have a number of nodes configured like this, and you would provide the right inputs. You would say, I would want 10 instances of microservice 1, or 20 instances of microservice 2, or 40 instances of microservice 3. So these are the inputs you would provide to Kubernetes, and Kubernetes would take care of deploying them to the cluster and meet your needs. And the managed service to be able to do this in Google Cloud is Google Kubernetes Engine. So if you have complex microservices architectures, that's when you'd go for Google Kubernetes Engine. The last service which we'll be talking about is a little different from all these. It's called Cloud Functions, and it is the serverless offering. It's serverless function as a service offering in Google Cloud. Now, what is serverless? Typically, whenever we talk about applications, the first thing we'll be focusing on is where to run the applications. I would want this kind of server, this kind of operating system, this kind of runtime, this many instances. This is how I would do load balancing and all that stuff. How about not worrying about all that and only worrying about your code? Just worry about your code. Don't worry about anything else. You can give the code to the cloud platform, and the cloud platform would take care of all the features, availability, scalability. Everything is taken care of by the cloud platform. If this function gets 10 requests, the cloud functions would automatically scale up to handle that. If there are 10,000 requests or 10 million requests, the cloud functions would automatically scale up and take care. You just need to provide the code and a little bit of configuration along with it, and the cloud function can auto scale to whatever limits based on the requests which are coming in. And the amazing thing is the function as a service offerings, you would pay based on the invocations. So if there are 10 invocations, you'd only pay for 10 invocations. If there are 0 invocations, you'd not pay anything at all. If there are 10 million invocations, you'd pay for 10 million invocations. So pay per use, and the fact that you don't worry about the servers is the key selling point for the function as service serverless offerings. And Cloud Functions is the Google Cloud managed service, which provides you with that specific approach. Right now, we looked at some of the important compute services related to Google Cloud, where you deploy your REST API. We talked about using a virtual machine, doing everything manually using Google Compute Engine, going for cloud load balancing to load balance. Or you can go for managed services like App Engine or Cloud Run. Or if you want a complex microservices architecture, you can go for Google Kubernetes Engine. Or if you want to take a serverless approach, you can go for Cloud Functions. These are some of the important compute-related options that are present in Google Cloud. Now that we talked about compute, so these are the compute-related things that we talked about until now. Let's move to database. Right? What we are talking about in here is a transactional database. Right? This might be a banking application or a financial application or a shopping application where there are a lot of transactions. There might be thousands or millions of transactions per second which are happening. And each of these transactions will involve small updates. Maybe 5 rows are updated, 10 rows are updated. These are typically called transactional applications. And therefore, for this specific use case where we are having transactions, we will need transactional databases. Let's look at them. So whenever we talk about databases, there are 2 types, right? Relational databases which support SQL, and other databases which are typically called NoSQL databases. Whenever we talk about SQL databases, these have very well-defined structure. So you define tables, you define columns, you define relationships between them. Let's say this is the order table, this is the customer table, this is the product table. The order table has a foreign key to the order table. Sorry, the order table has a foreign key relationship to the product table. It has a foreign key relationship to the customer table. So you would be able to define transactions as well. You can say a transaction involves these many steps, and only when all these steps are met, you need to commit the transaction. Otherwise, you don't need to commit the transaction. So there is a lot of rigidity which is associated with typical relational databases. You have very strong transactions. You have well-defined schema. You also get strong consistency. Once you make an update, once the transaction is committed, whenever anybody reads back from the database, they would get the most recent update. So these provide you with very, very, very high consistency as well. Now, when do you go for NoSQL databases? You go for NoSQL databases when you need very, very high scalability. So what we are talking about in here is not 1,000 or 10,000 transactions per second, but we are talking about millions of transactions per second. So we need millions of transactions per second, and that too at very, very high performance. So we are talking about, let's say, millisecond responses. So I would want responses back in 0.001 second. So that's the use case when you would go for NoSQL database. You want high scalability and performance. However, NoSQL databases don't provide you with consistency guarantees. So you might have made an update, but the update is not immediately reflected for all the users. In those kind of use cases, scalability is much more important than consistency. Good examples are social media use cases, right? So if I'm making a Facebook post, if it does not appear immediately in my friends' feeds, I'm not really worried, right? If it's appearing after 10 seconds, 15 seconds, it's okay. It's not a big problem. The same is the case with Twitter tweets or LinkedIn posts or Facebook posts. Any of those, like the consistency can be little low. So these provide you something called eventual consistency. So if you give a little bit of time period, 10 seconds, most of the times it's within a second, the data is automatically replicated to everywhere, and everywhere you would get the same updates. However, they provide you with high scalability and performance. Facebook, Twitter, LinkedIn, all these need very, very fast responses, even though there are millions of requests which are happening per second. So these are the categories of the database. Let's look at the specific offerings in Google Cloud in each of these categories. In Google Cloud, if you'd want to run SQL, you have two different options: Cloud SQL and Cloud Spanner. Now, when do you go for which one? If you want a regional database, so if your application runs in a single region only, or you are okay with giving lesser amount of performance for users from other regions, and you're okay with good amount of availability, 99.99% is good amount of availability, if you're okay with it, or you don't expect your data to grow beyond 64 terabytes. So that's the max that Cloud SQL supports right now, right? So if you're okay with these limitations, you can go with Cloud SQL. Typically, databases like MySQL, PostgreSQL, MariaDB, those are the things which are supported by Cloud SQL. Now, if these are not sufficient for you, if you want a global database, if you want horizontal scalability, if you want 99.999% availability, and you want unlimited storage, and you want to get all this with strong schema, strong transactions, and strong consistency, that's when you go for Cloud Spanner. Cloud Spanner is the global relational transactional database which is provided by Google Cloud. Now, these are the SQL options. You would go for these SQL options when you need high transactions, strong transactions, and strong consistency. Banking applications, financial applications, that's when you would need all these guarantees. You'd go for NoSQL databases when you have a social media app. Consistency might not be so important for you, but scalability and performance are the most important ones. That's when you go for the NoSQL databases. And the recommended NoSQL database in Google Cloud typically is Firestore. It's called Cloud Firestore. Earlier, this was called Data Store. There is another option also present in Google Cloud, which is NoSQL. If you have time series data, or if you have huge volumes of streaming data which is coming in those kind of situations, you can go for Bigtable. However, for most transactional kind of applications, we would recommend going with Firestore and Data Store. Bigtable is only recommended when you would want to be able to retrieve based on a single key for time series or huge volumes of analytical data and things like that. So those are the transactional databases. So what we are looking at is in here transactional databases. Basically, huge volumes of small updates of 5 rows, 10 rows. That's the max. The alternative databases, like alternatives to transactional databases, are analytical databases. These are databases where you probably load data at one time or regularly once a day or twice a day or once a week. And you'd want to do complex querying around it, right? These are typically called analytical databases. Analytical databases also allow data coming in streams, but most of the times data is loaded as a batch. And these databases support huge queries on petabytes of data. So you would want to be able to queries on petabytes, exabytes of data, huge volumes of data. So this data might be coming in from multiple other databases as well. So the service in Google Cloud which provides you this feature is Google BigQuery. This is my favorite service in the cloud. If you ask me which is my favorite service to use in the Google Cloud, I would say it's BigQuery, especially because it has revolutionized the data warehousing industry. Earlier, data warehousing setup and doing data warehousing is very, very complex. Getting the data to one place, getting intelligence out of it was a big headache. And I think with its serverless compute and serverless storage approach, BigQuery almost revolutionized the entire industry of data warehousing. BigQuery, that's why, is one of my favorite services in the cloud. So if you are going for analytical database in Google Cloud, there is no other alternative. Go with BigQuery. And now you'd want to get intelligence from it, right? If you want to, let's say, create dashboards, reports, visualization, you would want to be able to run workloads around BigQuery and get intelligence from it. That's when you would go for business intelligence kind of things. Typically, the managed services which are provided are Looker, or if you have simple use cases, you can also go for Data Studio. So these are the two services which are present in Google Cloud for visualization and getting business intelligence. You might also want to be able to run machine learning and things like that, but that I will keep that out of this discussion because this specific thing is meant for beginners. And I don't want to really get into machine learning services using Hadoop or Databricks or most of the AutoML related services which are provided by Google Cloud. Let's not really worry about them for now. So let's focus on these things right now. So until now, we looked at compute, database, two types of databases, transactional and analytical databases, and we looked at business intelligence. And now we shift our attention to front end. If you want to run a front-end application, typically you can make use of a VM as well. You can make use of a VM, probably set up a HTTP server there, and then put your content there, and you can serve it from the VM. And you can also scale it up by creating multiple VMs as well. But that's not the recommended approach which is suggested in the cloud. Typically, in the cloud, we would make use of object storage. Now, before we get to object storage, what we'll also discuss is the different types of storages which are present in the cloud. So typically, whenever we go to the cloud, we talk about three types of storage: block, file, and object. Now, what's the difference between these three? Let's say I have a VM, and to it, I would want to attach a hard disk. Right? This is similar to a hard disk which is attached to your computer, a VM. One hard disk is attached to one VM only. This is what is called block storage. At a point, the hard disk is only attached to one VM. However, to one VM, you can have multiple hard disks attached. But you cannot attach the same disk to multiple VMs. That's not allowed. A single block storage device is typically attached with one VM. Now, the alternative is something called file storage, where I would want to have a file share that is shared between multiple VMs. So this is what is called file storage. In Google Cloud, whenever we create a VM using Google Compute Engine, a disk is created using persistent disks. Google Persistent Disk is the service. And if you want to create a file share, you would go for file store. So file store is the file sharing service in Google Cloud. You can create a file store and you can physically attach it with a VM. The important thing in here with respect to block and file storage is that these are physically attached with the VMs. So you'd create a VM and the VM has direct connection to the storage device. However, certain situations, you might want to expose APIs to upload objects and things like that. For example, you are running a video management application or an image management application or an audio management application. Users are uploading a lot of files and you'd want to store all these files. So users upload and download the files, right? So this is nothing but object management. So this is where you go for object storage. Typically, object storage services provide you with REST API. So REST API is provided. You use the REST API to upload the object using a key value pair. So you would have a key, the value is the content of the object, and you would upload it. So if you have a video file, maybe the path to the video file and the video name is the key, and the value is the content of the video. And you'd be able to use a REST API to store the object and retrieve it back as well. So object storages allow you to store multiple objects using key value pairs in a bucket kind of thing. And the amazing thing about the object storage service in Google Cloud, actually, this is something which is common to all object storage services. The object storage service in Google Cloud is called cloud storage. So Google Cloud Storage, or just cloud storage, is the object storage service in Google Cloud. This is very, very similar to S3 or blob storage in Azure, S3 in AWS actually, and blob storage in Azure. And cloud storage actually can be used to host static websites as well. So the front end files which you have, it might be JavaScript, CSS, it might be images. All of these you can upload to cloud storage, and you can actually expose a website using cloud storage. On the bucket with very, very simple configuration, you can actually expose it as a website. So the recommended approach to expose a front-end application, a React, Angular, or a Vue.js application, or any static website, is to put it into cloud storage and expose it out. Now, there is one requirement which is typically needed for front-end applications. One is URL, right? So typically, you would want to be able to say www.in28minutes.com, and you'd want to be able to reach the website. The second thing is you'd want to distribute geographically. Your users might be present all around the world, and you'd want low latency for all users. They should be able to access your website quickly, right? So in those kind of situations, what you can do is distribute the front-end content to multiple locations around the world. So there are services which help you to do these in Google Cloud as well. So this is called domain naming service, DNS. And in the Google Cloud, it's Cloud DNS, which is the service to allow you to map a name, a URL, to where your thing is hosted. And you can also do geographical distribution. This is called CDN, and you can easily guess the name, Cloud CDN. So Cloud CDN is the service to distribute your content to across the world so that users from around the world get low latency. So what we are looking at right now are some of the important services related to storage. We talked about block storage, which is to create hard disks, file storage to create file shares, object storage to be able to upload and download objects using REST API, and also to expose a static website. Object storage has a number of other use cases. Typically, whenever you are migrating from one cloud to, migrating from your data center to the cloud, in that kind of situation, you can use object storage as an archive location as well. A lot of times, whenever we are creating data pipelines to move data from one place to another place, object storage is used as a temporary location. So there are a lot of other use cases for object storage. So don't really worry about it. If you understand block storage, file storage, whatever is not block storage and file storage typically gets into object storage kind of a thing. Right? So that's about storage. So until now we looked at compute, storage, database, and last thing, which is very, very important in the cloud, is networking. Right? Until now, we did not talk about networking at all. Whenever we get into the cloud, what we have is a shared infrastructure, and therefore security is very, very important. And therefore, it's very, very important to understand the networking concepts really, really well. So let's say I have an application, and this is talking to a database. If this entire setup is in a data center, nobody outside this network would be able to see what's happening between the application and the database, right? So how do I get some similar kind of setup in the cloud? Even in the cloud, I would want to set up my resources in such a way that I don't want anybody else to be able to see the communication which is going on between those resources. I would want to be able to control what traffic is coming in, and I would want to be able to control what traffic is going out from here. That's where you would go for something called virtual private cloud. What we'll do is we'll create something called a VPC. So a VPC, a virtual private cloud. In Google Cloud, it's Cloud VPC. So if you have multiple resources which are present, and if they're talking to each other, if you create them within a VPC, the communication between them is not visible to the outside world. And you can control the incoming traffic for each resource, and you can control the outgoing traffic to each resource. Inside VPC, you can create different kinds of resources. Some of these resources might need access from internet. Let's say this is a web application. You might want to have access over internet to this device. But for this one, I don't want to allow access from outside. I don't want to allow a database. I don't want to allow access from outside the network. Only devices which are present inside this network should be able to talk to it. So these are called public resources. These are called private resources. And how do you create public and private resources in the cloud? The best way would be to actually create something called a subnet. So you can create a subnet. This is a private subnet. Actually, this is a public subnet, because this is where your web application is. So a public subnet, a user will be able to access this application from the internet. However, inside a private subnet, you can configure rules in such a way that nobody from outside will be able to directly talk to it. Only applications in a public subnet or from inside this specific private subnet will be able to talk to this. This would ensure that you have good security for your applications. So nobody will be able to connect to the database directly. If somebody needs to connect to a database, they would need to log into a specific VM which is inside this specific network, and then be able to connect to the database and perform operations. So you'll be able to control what traffic which is coming in, which traffic is going out from your network by using VPCs and subnets. So these two in here are subnets. In addition to this, let's say this is the data center that we have. In addition to this, we would want to establish a connection with our data center, right? Sometimes you have resources in here which might want to talk to an application which is present in here. How do you establish a connection between these? That's where you go for a cloud VPN. So a cloud VPN helps you to establish connection over the internet between your data center and the cloud. Important thing, this is over the internet. So it's very, very important that every piece of data which goes in should be encrypted. And that's the reason why this uses IPsec protocol. Sometimes you don't want to use a public network for your communication for the communication between your applications. That's where you can go for dedicated connection. So that's where you can say, I don't want to use that. I want a dedicated connection, and this is called Cloud Interconnect. In Google Cloud, Cloud Interconnect can be used to set up dedicated connections between your data center and the subnet. So until now, we looked at some of the important concepts related to databases, storage, compute. We looked at 4 important concepts which are related to networking, which is subnet, VPC. We looked at Cloud VPN and Cloud Interconnect. Before we end this video, let's talk about something really, really important. DevOps, right? It's getting infrastructure and application in place is good, but you want to be efficient in how you do your processes as well. And that's what DevOps helps you to do. And when it comes to DevOps, you would look at 4 different operations typically: CI, CD, continuous integration, continuous delivery. We also look at infrastructure as code. And we also talk about observability. I'm just picking up some of the important ones. There are a lot of other aspects related to DevOps as well. Let's focus on CI/CD, IAC, and observability. If you are interested in talking about DevOps, understanding what is CI/CD, IAC, observability in depth, we have a separate video which is created on DevOps, where we talk about DevOps outside the cloud and also in 3 different cloud platforms: AWS, Azure, and Google Cloud. You might want to look that up. Over here, we'll just touch upon at a very, very high level. So if you would want CI/CD, continuous integration, continuous deployment, if you want to do something as soon as a piece of code is committed, you'd want to run your unit test, you'd want to do your static analysis, you'd want to deploy your application to a test environment or even production environment, you'd want to run your unit tests and things like that. This is what is continuous integration, continuous delivery, continuous deployment. And in Google Cloud, the service to be able to do that is Cloud Run. Google Cloud Run would help you to run pipelines for continuous integration, continuous deployment, and continuous development. Actually, sorry, continuous delivery and continuous deployment. Now, what is infrastructure as code? You don't want to create infrastructure manually. If you want to create a VPC, a subnet, another subnet, a resource in here, a database, establish connection, a lot of resources need to be created in the cloud. And you need to create this in multiple environments, dev, QA, stage, production. This is not easy. And that's why you would need to automate the provisioning of this. This is where infrastructure as code comes into picture. The popular tool to do infrastructure as code is Terraform. In Google Cloud, you can make use of Google Cloud Deployment Manager. So it's Google Cloud Deployment Manager, which you can use to do IaaC in Google Cloud. I would say the recommended one would still be Terraform. I don't really like the Google Cloud Deployment Manager. I would recommend you to go with Terraform if you are using Google Cloud. Now, let's talk about observability. Observability is all about getting metrics, logs, traces from your application, getting observability into your application, being able to solve production problems quickly, being able to identify production problems quickly. That's what observability is all about, right? So typically when we talk about observability, we talk about metrics, logs, and traces. So the metrics might be related to your cloud resources or related to your applications. And in Google Cloud, it's cloud monitoring. So cloud monitoring is responsible for all the metrics related to managed services as well as your applications. You can add a few, you can add code to your application to send data out to cloud monitoring as well. There are a lot of libraries which are available, which makes it very, very easy to send data out to cloud monitoring. And if you want to send logs, you have cloud logging. Cloud logging is the centralized logging service in Google Cloud. You can send your application logs, the managed service logs go into cloud logging as well. And you should be able to guess the thing. Cloud tracing allows you to trace requests across multiple things. Whenever we talk about microservices architecture, the requests go across multiple services. When you want to debug problems, you want to be able to identify, hey, where did it start? How did it go? This is what is called tracing. And in Google Cloud, the service which allows you to do this is cloud tracing. So those are some of the important services which are related to DevOps in Google Cloud. Now, the entire objective behind this specific video was to give you a high-level overview of the different services which are present in Google Cloud. When I started with Google Cloud, to get this perspective, it took me a few weeks. And I did not want you guys to go through the same struggle. And that's why I created this video. I thought I would take a full stack application as an example and kind of take you through the entire journey. If you like this journey, then I'm sure you would be interested in doing one of the cloud certification courses as well. We offer cloud certification courses in Azure, Google Cloud, and AWS as well. And if you are beginner to the cloud, I would recommend you to start with either Google Cloud Digital Leader or AWS Cloud Practitioner or AZ900, which is Azure Fundamentals. Those are certifications which you can typically do within a couple of weeks, 2 to 4 weeks, should be more than sufficient if you understood this entire video completely. So if you want to formalize your cloud knowledge, that might be a great option to consider. I hope you had a great time watching this video, and I'll see you again. I'm sure you had a great time watching this video. Do not keep it to yourself. Tell your friends and tell YouTube as well. How do you do that? Like, share, and subscribe. If you're looking to get cloud certified, check out our cloud certification courses in AWS, Azure, and Google Cloud. And do not forget to check out the other videos in this series of videos on cloud fundamentals. If there is a cloud topic that you're feeling it's very, very difficult to understand, do post it in the comments and we will make it simple for you. I'm sure you had a great time watching this video, and I'll see you again very, very soon. Until then, here's bye from Ranga at In 28 Minutes. See you soon.